All right, everybody, welcome to Earth Science, page one of the Hawaiian Island Formation Lab. So, what we're going to do here is a graph that people consistently think is a map. It's not a map, it's a graph. It's a graph that compares longitude to the age of the island. How old is the rock in that island? An active volcano like Hawaii, we can say some of the rock in that island is pretty young, half a million years, 500,000 years, up to today. There's rock that forms that within the last couple of years in the active part of that island. But some of these are older, right? So where do they fall longitude wise relative to their age? And we'll see if we can get the trend. This is a map. And in fact, this is a map that used to be part of this lab that I've kind of stolen from bits and pieces. You used to measure between all those dots, but I've turned that into a Google Earth thing. You'll see that soon. So this is a map of the Hawaiian Islands. There's the main one. And if you did the other part and saw the animation, hopefully you're starting to see how this works. The plate is moving that way over top of the hot spot, and the hot spot is currently pumping magma out of that volcano right there. So where might be next? All right, so we got a couple things to think about here. There's a couple places where people might get confused. First off, that is blank on purpose so that you can figure it out when you do question number 3. So don't say, why is that blank? You're going to do it later. Don't worry. Second, we got to deal with partial degrees, which at this point of the year, in like a normal year, I think people are more comfortable with. We did less mapping this year with all the COVID situations. So I don't know how many people remember what 30 minutes means or 15 minutes means. The idea is that each degree is broken up into 60 minutes. So 155 degrees and 30 minutes is kind of the same thing. In fact, here's what we'll do. It's kind of the same thing as saying 155.5 degrees. In fact, I wish we could just do that in New York State. They still make us do this minutes and seconds deal. But whatever, we can figure it out. So if it's 155 and 30, that's 30 minutes out of 60. That's a half a degree. 158 and 30 would just be 158.5. 15 is like a quarter. 156.25. That's the idea. So 177.5. You want me to do all these? That's it. Okay. You got to pay attention to those west and east. It's very easy to spot when you make that mistake. Um, and I didn't write them in there, but that's the idea. Now, look how big a box for a degree is. So is it going to be a big difference between a half a degree and a quarter degree? Not at all. But try to do the best you can. Make it as accurate as you can. You'll do great. Next thing we got to worry about is what's going on down here on the x-axis. Let's go back and look at Hawaii again. So Hawaii, if you want to think in a Eurocentric way, where we can turn on a grid here. Mm-hmm. So there's your prime meridian in yellow that goes through Greenwich, England. The British made sure that they lived. Everybody else lived relative to Britain. Um, and then you got the Western Hemisphere with longitudes going that way, Eastern Hemisphere with longitudes going that way. So in that Eurocentric sense, Hawaii is kind of back here on the back of the planet, where you get this line at 180 degrees. We call the international date line. So in this graph, you're going to have to deal with both Western longitudes and Eastern longitudes, with the West ones counting that way and the East ones counting that way, all up towards 180, which maybe sounds more complicated than it needs to be. It's not very complicated. Here's what we'll do. We'll say that these, let's draw an arrow down there, count that way. Those are your west longitudes. So if you're doing west, just count from right to left. And if you're doing east, they come from left to right. Okay. And you kind of experienced that if you did the previous lab. So that should be no big deal. So let's do it. If Hawaii has an age of a half a million years and it's at about 155.5 west, 155.5 west is right about there. 500,000 years, each of these is worth 2 million. So the first one's kind of the harder one. So 155.5 and a 500,000 when each box is worth 2 is only going up like a tiny little bit in the box right about there. I don't know what size you want to do, maybe 4. I wouldn't do giant dots for this. That should do it. At one point, I had people label all these. Let's skip labeling them. We don't have to do it. All right, there's your first one. Done. That guy, I'm not going to try to say it. 39 million years at 170 east. Perfect. This will give us one in each. So 170 east, I'm counting that way. It's right there. And up to 39 million years. Maybe right about there. There you go. 2 done. All right. What do you think? You guys do the rest of those. This is blank on purpose. You'll come back to it when you do the questions, and you'll be set. Okay. So that'll do all of. Please plot them. I'm stopping here. I want you guys to do that work. Go ahead and plot the rest of those, and then draw a straight best fit line. We did do this on a previous lab. You should have done this with the bead drop lab. Your dots, they're going to roughly follow a pattern that goes right down through here. Okay. So I think we have a line tool on here. Yeah. So what one line that you can draw, and maybe make it a different color so it sticks out a little bit. What one line can you draw? I don't know how this tool works. Okay, click and drag. That is best representative of all the dots. They're not going to fall. I mean, if I only had 2, easy peasy, right? There's going to be more on here. They're not all going to fall directly on the line. Approximate and say what one straight line can go down through all those the best. It's going to look pretty much like that, but there will be more dots around. You might have to futz with it a little bit. Just erase it if you make a mistake and start over. It's wicked easy. This is way easier than doing it with pencil and paper, believe it or not. All right, so that'll be that job. You can do it. Then what do we got? Which island is youngest and oldest? You can just grab that from the data table or from the graph, whichever one you're better at reading. What's your relationship between longitude and island age? We should get in the habits. I haven't been pressing it as hard this year, but when you get a relationship question, you always say as. Then you say the first thing. Longitude. Of course, and we usually say increases or decreases, right? So that doesn't really make sense in this context because you go from west to east. So maybe we'll say like, you can pick either one, honestly. Why don't I leave it to you? As longitude goes west or as longitude goes east? You tell me. So you're going to tell me that in this blank. As longitude goes west or goes east. Then what happens to the other thing in the relationship question, which is in this case? There's your format. There's 2 possible ways to answer it. Both correct. 2 possible ways to answer it incorrect as well. 3, Neoha was left blank on purpose. How can you figure it out? Well, you got a line on there. You have Neoha's longitude. So given their longitude at 162, where does 162 hit your line? You go up, over. That's about how old it is. Looking at the map of Hawaii, what happens to island size as you go west? This is going to be a recurring theme. Hopefully you thought about that with this question right here. This is a similar concept to what you hopefully wrote right there as you watch that video. But as you go further away to the older and older islands, what's happening to the size? All right, there you go. Front page done. You guys are getting there. Excellent news. Keep it up. And more pages to go. We'll do those in different videos. Thanks.